I hope that as you're working through these stoichiometry videos, you're starting to see the pattern and how we solve them. The final new addition, although we'll have to keep using some of these ideas for the other types of problems we have, is when we go from grams of what we're given to the grams of what we're looking for. I call these the big kahuna of stoichiometry problems because they involve all three steps. So in the case of going from grams to grams, remember when we're kind of thinking of our map here from your textbook, here in the yellow, the letter A represents what we're given. And then here in the peach, this side represents what we are trying to find. And in the case of grams to grams, what it means is we're going to be given grams, and we have to come all the way over here to grams. So to see that, you have to go through step 1, which is to go from grams to moles. And grams to moles, we know that uses the molar mass. Then once we have our answer of moles, we're going to do step 2, and that requires the mole ratio from the balanced equation, and that will get us into moles of what we're trying to find. And then finally we'll have to go through step 3, which will be going from moles to grams, and that again is going to require the molar mass. So in a 3-step problem, we use the molar mass of what we're given, we multiply by the mole ratio, and then we use the molar mass of what we're looking for. So let's take a look at this problem. We'll do 2 problems in this particular video. If you want to see more examples, you can go under class lessons. So it says, again, read the problem to find out there's important information here. So we say how many grams of nitrogen. So I look and I see, okay, I'm trying to find this nitrogen and in grams. And then are required to react with 12 grams of hydrogen. So then I see here, this is what I'm given, and I'm also given in the unit of grams. So one thing I know in all of these problems, not one step this would not be appropriate, but in 2-step or 3-step problems, if you have a gram, either that you're given or you have to find, you're going to have to use the molar mass in that problem. So I'm going to go ahead right now and calculate the molar mass. So nitrogen is 14.02, but I have 2 of them. So in this case, it's going to be 28. Oops, it's 14.01, sorry, 0.02 grams per mole. And then hydrogen is 1.008, but I have 2 of them, so that's 2.016 grams per mole. I know because I'm given grams and asked to find grams, I'm going to need the molar mass in both of those. The ammonia I don't care about because it wasn't referred to or asked about in the problem. So how many grams of nitrogen are required to react with 12 grams of hydrogen? So we always start with what we're given. And so if I'm given grams, my first step is I can only use the molar ratio with moles, so I first have to convert it into moles. So I have grams here, so I'm going to divide, 2.016. I'm going to divide by the molar mass. I like to write hydrogen there because in these problems, when I'm working with 2 different substances, I always like to keep track. So if you're doing it step by step, 12.0 divided by 2.016, and I get, don't round at this point, 5.952. It keeps going. I'm just going to leave it in my calculator. Moles of hydrogen. Now, in the previous video, I mentioned using a continuous problem, and I do have some that I solve in continuous. It's not required. This is where you're practicing, and you working it out is going to make it work best for you. So you can do this in individual steps like I'm doing in this problem, Or you can set it up continuously, where after each step you don't get an answer and you don't put it all into your calculator till the end. So if I'm doing it this way, now I'm here, I have moles of A, and to go over to moles of B, I'm going to multiply by the mole ratio. I'm writing kind of small because I jammed myself into the corner. So I have the hydrogen, and so let's see, in front of a hydrogen is a 3. What you're given goes on the bottom, so it will cancel. And then what I'm looking for, nitrogen, there's a 1 in front of it. So the moles of hydrogen cancel. And so it's going to be the number I had, 5.952, divided by 3. And I get 1.984, and I really have put too much on this slide. I apologize. And so there I get the answer of moles. So now on my step, I'm right here. And so now I need, the answer needs to be in grams, and I know to go from moles to grams, I'm going to use the molar mass. So I'm just going to attach it here so I don't. And my molar mass of ammonia I calculated here. So I'll put the 28.02 grams per mole. The moles are going to cancel. So I take the moles I got and multiplied it by 28.02. And I get 55.595. How many significant figures? Down to 3. So I'm going to go 55.6 grams of nitrogen. Ooh, and what a little mess of a slide. But anyway, you've thought through the whole process with me. Okay, so the question was how many grams of nitrogen are required to react with 12 grams of hydrogen. So it would take 55.6 grams of nitrogen to react with those 12 grams. Now I've given myself a little more room here, so that's going to be good. And if you want to, you can pause and see if you can kind of try to set it up. Or all along the way, you could pause, like do a little pause, do a little pause. So what I want to think about, and this is what I want your goal to be, the process of these stoichiometry problems. Remember, I'm writing in blue what's given. So you can either be given grams or moles for your units, right? And then what we're going to be asked to find, and I'll put these in pink, are either going to be moles or grams. And depending on where you have to stop and start, that's going to depend on the steps you do. And to go from grams to moles, I have to use the molar mass. Moles to moles is the ratio, and then moles to grams is also the molar mass. So depending on where you start and stop is going to depend on how many steps you do. The maximum number of steps you're going to do is 3, right? Okay, so I start with my balanced equation. We're getting a little better at this. We read the problem. How many grams of the bismuth sulfide? So here is what I'm trying to find. And they asked me to find it in grams. And so looking at my little plan, I see that I have to get all the way over here to the grams. And then I read are produced from 200.7 grams of H2S. So here's the H2S. So this is what I'm given, and I also need this in grams. So that means what I'm given is in the blue part. I have to start here. So I think to myself, okay, this is going to require 3 steps. I have to use the molar mass to go from grams to moles. Then I'll have moles of H2S, and I'll have to use the ratio, the second step, to get to moles of bismuth sulfide. And then I'll have to go, my third step is to go from moles to grams. So I see I'm going to require to go from grams to grams requires 3 steps, and I know I'm going to need the molar mass of both things. So I'll start with H2S, and I'll get its molar mass. So hydrogen is 1.008. I have to multiply it by 2 because there's 2 in the formula. And then sulfur, I gotta look at my periodic table, is 32.01807. 32.07. And so I add those two numbers together. 32.07 plus 2.016. And I have 34.086 grams per mole. And then I also need, okay, so what I'm trying to find is bismuth sulfate. So bismuth, the second 2S3. So I have Bi, which is, let's look on our periodic table. We've got to find bismuth, and it is 209.0. Now I have two of them, so I have to have 209.209 times 2, and that's 418. And then the sulfur is 32.07, but I have 3 of them. So I have to multiply that by 3 times 3, and I get 96.21. And so then I have to add those two together. So 96.21 plus 418, and it's a big molar mass. I get 514.21. Okay. So let's try to solve this problem. So the first step, I'm going to start with grams, with what you're given, and I'm going to use the molar mass and convert it to moles. So I'm given H2S, so I'm going to put the molar mass of H2S on the bottom, the moles, and I will get the number of moles. Now, if you like to do this as a continuous problem, then go ahead. Don't get an answer here. You're just going to write another multiplication sign and get ready for the ratio. And I get 5.888. And I do not round. If you're doing this in steps, don't round here. Okay, I'm just leaving my number in my calculator actually. So now I've gone from here to here. I have moles of my H2S, which is what I was given. So the second step is going to be to use the ratio to get it over to moles of the bismuth sulfide. So I take the 5.888 moles of H2S, and I'm going to multiply by the ratio. So what I was given, the ratio, H2S is what I was given, that has a 3. And what I'm looking for has a 1. So I'm going to multiply by 1 and divide by 3. Now again, since it's a 3-step problem, if you are not getting answers and doing it as a continuous problem, don't write anything down. Put a multiplication sign and get ready for the next step. I prefer the continuous problem simply because I make fewer mistakes when I keep having to rewrite things. So my final, now I'm here, and then my final third step would be to use the molar mass of and go to grams. And so I'll take that number and multiply by 514.21. And I get a big number, 1009.23 grams. And if I wanted to do significant figures, 4. So if I wanted to do significant figures, I will just erase that. And 1009. And this is, I better put what I'm calculated, this is bismuth sulfide. So that's the 3 steps. And again, if you want to see it done, not this problem in particular, but if a lot of the ones on the class lessons I've set up as continuous problems. And so if you'd like to see that, there's more problems in class lessons on these type of stoichiometry problems, calculations.